the functionality of bitwise OR operator, the functionality of bitwise OR operator is shown below. So here I am going to write it. The truth table I am going to write it. So what is the value of value 1? What is the value of value 2? Come on, answer. Not reading and coming, correct? So the value of value 1 is, what is that? True. Bitwise operators are applicable only on integer data. My question is, value of value 1 is integer data. Value of value 2 is integer data. True, false. Who said that true or false? Waste knowledge. This is called what value 1, value 2 are integer data. Last class only I said bitwise operators converts integer data into binary format. The value for value 1 is integer data and again integer data. If I convert into integer data, the value of value 1 can be binary format will be coming. This can be a 0, this can be a 0, this can be 1, this can be 1, this can be 1 or 0, or this can be 0, this can be 0. And this is called 1 and this is called 1. These are the possibilities we can say. Possibilities of what? Value 1, value 2, these things are there here. So I'm going to talk about it. Value 1, value 2, I'm talking. 0, 1. The OR operator says that any one of the bit is 1. Result is called 1. Result is called 1. Any one of the bit is called 1. Result is called 1. If both the bits are 0, result is 0. So what is the next answer? 1. Next answer 0. Next answer 1. So this is the subject of truth table what we used to get it. So if I come to an example here, if I come to an example 1, go to the Python environment now. Go to the Python environment, taking here. So I'm going to have it. So there I'm writing 0 or 1 is called 1. 1 or 0 is called what? 1. 0 or 1 is 0 or 0 is called 0. 1 or 1 is called what? 1. This is the truth table related part and that you already written in the table. This is very simple, not a difficult, and you understood. It doesn't mean that we are supposed to write here false. Some people will tell like this. This is called true. This is called 1 only. And the next is called what true. And what is this now? False. Also true. False or false is called false. True or true is called what true. And they are trying to show something like this. They are writing or. Answer is called what? True. They are trying to say both of them are same. They are trying to say, but it is not completely. That is a completely wrong answer. And whatever is there here, if you just look into this area, true or true, if I say, it is going to be called what? True only. And it doesn't mean that this answer and this answer is not going to be same. They are completely different. So OR operator is completely different from bitwise OR. As far as true and false is concerned, internally taken as zeros and ones only. They are taken as true and false values here. And finally, I'm going to move to the further. What is this concept here is, once again, I'm going to say how it is different from 1.2 or what 2.3. It is called error, type error, which is completely different from 1.2 or 2.3 is going to be, answer is coming. What is that? 1.2. So OR operator is completely different from bitwise OR. And this is a perfect explanation for this. Why people don't explain bitwise operators? Because they will say this is equivalent to OR operator. They will say it's not. You have seen practically here. And one more thing is, now I'm going to take up here. I'm going to answer this question now. Coming to this place, 4 or 5. I'm saying 4 or 5. So how it is working? There is no formula, students. Directly you need to calculate. What are the 4 binary? 0, 1, 0, 0. How many I'm taking? 4 bits only I'm taking. If you want, you can take what? Some extra bits also you can take it. With the zeros only will be coming. What is the next 5? What is the next value? 5, 0, 0. What is this now? 0, 1, 0, 1 will be taken. What the OR operator says? Already the table I said. What is this? 0, 1, 1, 0, 0, 0, 1, 1, 1. What is this now? 0. All of them are called 0 only. What is an answer here? 5. 5 is an answer here. 5 is an answer. Are you able to follow? Next, 3 or 4. 3 or 4. Here 3 is going to be calculate. 0, 0, 1, 1. And what is the answer of 4? 0, 1, 0, 0. What is the answer now? 1, 1. And next is what? 1. This one. 1, 0, 0, 1, 0, 1. Answer is called what? 7. Answer is called 7. It doesn't mean that we are adding here. They're not adding. This an OR operator is done. Next I'll go for what? 10, 10 or what? 15. 10 or 15 I am taking. 1010 is a 10. And next 1111 here. This is called what is an answer? It is a 1 and 11 also 1. 011 and this is also 1. Answer is called what? 15. It is not 25. So when these questions are coming, please be perfect in answering such questions in the interview point of view. So take care about that, this kind of answers here. So here I'm going to write another example. And if you try to write it, Python, as a string data, here we are writing Python and next or, and the next I'm writing Java here. It will give you what? Type error. And Python, if I write it, or if I write it, or if I write it, it will give the answer called what? Python. So I hope that you are understanding this Python here. So I think students, you are understanding about concept of how OR operator works. Understood? And the most important point, this is what I'm trying to tell you. The most important point I want to cover. If somebody asks you what is the real time purpose of this OR operator, where we can use it, where internally used in the product level development, where it is used in the application level, come to the point of it. S1 is equal to 10, 20, 30. S2 is equal to something like 20 and something like 15, something like 25 I am writing. Here I am writing students, S3 is equal to S1 dot union of what? S2. Union of S2. Print of S3. Print of S3, comma type of S3. What is the answer is going to come? Union. Already you know about what union will do. So union is going to do what? Take all the unique elements of S1 and S2 and put it in where? S3. So all the unique elements are coming now. And we got the printed here. This is about what? Union we learned already in the class. Coming to this case, now I'm going to introduce the next case students. S2 I'm saying S4 is equal to S1 bitwise OR operator S2. Inside of union, inside of taking this S1 and S2, merging of these two, I'm applying what? OR operator I'm applying. S1 or S2. How this is processing internally, how this is getting processed. Now I'm going to talk about it. How this is getting processed, I'm going to tell you. Listen very carefully. Here, all the students in online need to listen. Now I'm telling the process. All the values of S1 compared with what? S2. That is the first step. Second step, second process, all the values of S2 compared with what? S1. With what comparison? Bitwise OR comparison. How the bitwise OR will compare? In the form of bits, binary bits. So starting here, once again, all the values of S1 compared with S2, all the values of S2 compared with what? S1. Let us start the flow. So I'm taking the element called what? 10. I'm taking the element called 10. I'm taking the element called 10. When I'm selecting the element called 10 for comparison, that will be taken as what? 1. that will be taken as 1. When you select anything, that is on. That is on. On means what? It is considered as a true. When you select some element to compare, that element is on. On is nothing but what? 1. On is nothing but what? True state. So I selected 10 to compare. That is called 1. With what we are comparing? 20. 10 will be compared with every element, that element 10 compared with the 20 and compared with the 25. Next 20 will be compared with 20, 15 and 25. 30 will be compared with all the elements like this. So I hope that we are entering into the further. What is the element here? 10. 10. 10 is selected. That is called what? 1. 10 will be compared with what? 20. What is this is going to be? 10 is not going to be equal to what? 20. But 20 is not going to be equal to that on state value, which is going to be called as what? 1. Next, 10 is with what? 15. 10 is almost here 1. And next 15 is also like this. It is called 1 again. And 10 is with 25. This is going to be called something like this. It is also called 1. Why I am taking 0? Because here there is an element 10 which is not a 10 here, which is not a 10 here. That's why this one. So this OR case, what is happening? That element is going to be selected and added to whom? S4. Next I am going to get the 20. 20 is called what? On. On is nothing but what? 1. 1 is compared with what? 20. This is going to be called as what? 1 or 1 is called 1. Next 20 with 15. 1 or 0 is equal to 1. Next 20 with 15. 1 or called what? 0 is equal to 1. So 20 also selected. OR operator 1 means it is selected and going to keep it in where? S4. Next I am going to take with S3. S3 with 20, S3 with 15, S3 with this one. And 1 or 0 is equal to 1. 1 or 0 is equal to 1. 1 or 0 is equal to what? 1. So 30 also placed in where? S4. That is in the case of what? 10, 20, 30. All elements are selected and put it into S4. So S1 elements are compared with what? S2. Now I am going to enter into the S2 elements compared with what? S1. How do you compare? 20. 20. 20 is called 1 here. 20 with 10. 20 with 10. It is called what? 1. 20 with 20. 1 or 1 is called 1. 20 with 30. 1 or 0 is equal to 1. So that is called 1. We got it. That 1 is nothing but selected. But 20 is trying to add to that S4. But S4 was already containing 20. Second time 20 is not going to add. Second time 20 is not going to add because set allows what values? Unique values. Next 15. 15 is on. 15 is on. 1 or what? 0. 1 or 0. 1 or 0. 1 or 0. Which is going to be 1 here. 1 or 0, which is called 1 here. 1 or 0, which is called 1 here. The element 15 is added to what? S4. S4. Next is called what? 25. 25 is called 1. 1 with what? 10. Not equal. That is called what? 1 with 0 is 1. 1 with 0 is called 1. 1 with 0 is called 1. 25 also selected to S4. S4 contains what values? S4 contains what values? Type of S4, which is going to contain the data, which is similar to what? Previous union function only. I think you understood the comparison of what? How this is internally processed. I explained with everything. So I got the same as what? Union. Union operation internally performed with what? Bitwise or operator. Online students, I hope it is clear. I hope so. I hope so it is clear. Online students, respond it. So coming to the point of it, now I'll move to the S4. Offline students, did you understand? If you don't speak out, it's a problem for you. You understood or not? Yes. So try to speak out. So what is your problem? Are you able to understand? Next, we'll go to the next part of it. If you don't read and come to the class, sitting in the class, nothing will happen. 1.2, 2.3, 3.4. Another example. I am going to take up S2 is equal to S2 is equal to 3.4 and 4, 3.4, 2.3, 5.6. Now I am writing S3 is equal to S1 or S2. How the comparison will be? First of all, valid or invalid? Come on, invalid. So you are wrong answer. That's why I'm going to take this example. This is called invalid. This is called invalid here. This is called invalid. Separate values are there, that is called invalid. Because here I am going to take up what? On and off. On and off. Come on, now I'm comparing. This is valid. This is valid. That's what I'm going to discuss very deeply in the subject. Coming to the point of it. First S1 value selected, which is on, that is called 1. 1 with what? 3.4. 1 with 2.3. 1 with 5.6. 1 with 0. 1. 1 or 0 is 1. 1 or 0 is called 1. So 1.2 selected and added to S3. Next I'm going to enter into the 2.3. 2.3 is made a selected to compare, which is on. So 2.3 compared with 3.4, 1. 2.3 is compared with 2.3, which is called 1. 1 and 1 equal, this is. 1 and 1 is 1. 2.3 and 5.6, which is called what? 1. So 2.3 again selected and put it into where? S3. Next the 3.4. 3.4 is on. 1 or with what? 3.4. It is called 1. 3.4 with 2.3. 0 is called 1. 3.4 with 5.6 is called what? 1. 3.4 also added to S3. So that all the elements are added here. Next 3.4. 3.4. What is 3.4? Come on. 1. 1 with 0. 1 with 1. 1 with 0. 1. That is 3.4 already added to S3. It won't add again. 3.4 with 2.3. 1 with 0. 1. That is nothing but already 3.4 was there. Second time also not taking. 3.4 1 or 1 is called 1. So 3.4 was already there. This 3.4 once again it won't add because set never allows duplicate elements. 2.3 also it is on. 1 with 0, 1.0, 1.2, 1 with 0, 1, 1 with 1, 1, 1 with 0. 2.3 was not added to S3 because 2.3 was already added. Next 5.6, 1, it is on. 5.6 with 1.2. 5.6 is 1. 5.6 with 2.3, 1. 5.6 with 1, 3.4, 1. 5.6 added to whom? S3. Finally, S3 is containing what? S3 is containing the data called what, S3 is containing intersection of floating point values. When sets are there, this will be taking up. When separate values or floats are taking, this will give you error. Set of float values applied with bitwise operator, they are not going to take it as 1.2, 2.3. They are taken as what? Selection is 1, not matching is 0. That type of bit comparison will be taking place. So by seeing your faces, I don't know whether you got it or not. One more example, last and final. మీకు ఇంకా జ్ఞానోదయం అయినట్లేదు. So Java here. Next is called what? C. C. S2 is equal to Python, HTML, like this. Now I am writing S3 is equal to S1 or S2. Generally Python, this is not possible. This is not possible. This is an error. This is an error. Why? It is taking which values? String values. But here what are we taking? Set of strings I am taking. So what is the comparison start with? S1 elements with S2, S1 elements with S2, S1 elements with S2, S2 elements with S1. Start here. What is the first comparison? Python. When you selected for comparison, whose status is 1? and you are comparing with this Python. Are they same? Hmm. Same. Same means what? 1 or 1 is 1. That means that is selected. Kept into where? Yes, 3. Python with HTML also different. That is also God. So overall thing is what is selected? Python and put it in where? S3. Go to what? Java. Java status is what? 1. Java with Python 1 or 0? 1. Java is placed in S3. Java with HTML 1 or 0? 1. Java placed in where? S3. It is placed only one time only. Two times it won't place. Next C with what? C comparison is 1. C with Python, C with HTML. 1 or 0, 1 or 0 is called 1. That C is added to whom? S3. Next. S2 values with what? S1. Python is 1. 1 with what? 1. Python is selected, but it won't put it in S3 because it was already added. Python with Java, Python with C. 1 or 0, 1 or 0 is called 1, which was added, selected, but it was already added to whom? S3. Done. Next, I am going to take it HTML. HTML is 1. 1 with 0, 1. 1 with 0, 1 with 0, that is called 1. That is added to what? S3. S3. So S3 contains what? These three values plus extra what? S3. So put that S3 here. So got these values here. So bitwise OR operator works on what? Set of data also. On sets, whatever the type of values are there, they are working, but they don't work on where? They don't work on where? Separate floating point values, they don't work. Separate floating point values, they don't work. And separate string values also, they don't work. Are you able to follow? This is about concept of what? Bitwise OR operator. Very, very important. And if you take it, I already said to you, Python or Java, I already said, what is the answer now? Python. Because R is completely different from, in place of it, I already said to you, it is simply called what? Error. And these sets are containing string, but I am using it, it is perfectly valid. Are you following me? Right. So go to the place. Here I want to open it. A small concept I want to show you, students. Whatever is explained for you, that part I will show you here. Bitwise OR operator I want to show. Here you try to look at. Bitwise OR operator. Truth table is given here. And the truth table related example is given. 410 example is given. See here A and B values are given. See A or B is written 14. And 1010 is given here. A or B is given. In the beginning, some more example is given here. Here I wrote it. Here I wrote it. These examples are also available. So that I'll try to paste it here. Here. 4 or 5, directly here. 3 or 4, directly this value got it. And 10 or 15, this is the value we got it. These are all called what? Second example after the truth table, numerical calculations here. So coming to the point of it, example number 3. Example number 3 I'm going to talk. What is that example number 3? Sets with what function? Union function. What is this now? S3. Type of S3. What is this now? S3. With which function? Union. Or we can also do the union operation with what? Bitwise OR operator. Bitwise OR operator. How it is done, how the comparison is done, explained very clearly with multiple examples. Integer data. Next is called what? Float data. Bitwise OR operator. I took it as what here? Come on. This is going to be called as what here? String data. S1 of S2. Got the data. Python or Java. Simply it is called what? Error. Simply it is an error. Observe it now. 1, 2, 3. Set or 3, 4, 5. What is the answer? 1, 2, 3, 4, 5. 1, 2, 3. Directly I am writing this example here. Directly I am writing this example. And see this now. What is applied here? List data. What is the operator is applied? Bitwise OR operator gives what? Error. Why? Bitwise operators are applicable only on what? Sets. Not possible on which type? List type. Multiple examples. And here you see list data. And already That is already written there. 10, 20, 30, 10, 20, 30, bitwise or operator. 20, 30, 40, it gives you what? Error. Suppose if I write it as what here? Or operator I am writing or. So this is a non-zero. This is a non-zero. Non-zero is called what? True. What is the answer is coming? 10, 20, 30 is an answer is coming. This is another difference you are getting it. Students, I hope you are understanding me. What is my concept is. So coming to this place, here we got it. This is an answer we got it. And one more answer is what? Empty list or what? 10. What is an empty list is called? 0. What is this 10 is called? Come on. 1. That is called answer is what? 10. Mississippi or Mississippi is going to give you what? Error. Why error? Because string. Only individual strings not possible. Individual string not possible. Set of Mississippi and set of Mississippi. It is going to be called what? One set with another set. Are you getting or not? Yes. And a set of 10, 20, 30 or operator is applied and also got the result. So list or list is not coming, but the list elements are converted into which type? Set type. I hope you are understanding me. This is about what? Bitwise or operator. Even already I said tuple here. Already list I said. Tuple also same nature. Don't get such type of low level doubts. Try to understand. Once if I say list, don't try to get the doubt about what about the tuple. Because of not reading notes, you will get such type of problem. Try to take it. Huh? In tuple possible or not. Ankit, please read the notes and try to get such type of unstable doubts. Because of unstable doubts, you will lose your subject. Read the notes well and try to. Is tuple is possible or not? These are all called unstable doubts, not a proper doubts. Try to improve your doubt capacity. It is called what? When tuple is when a list is problem, tuple is also problem or not? Bitwise operators are applicable only on but not on other type. Already said. Are you okay, Ankit? So coming to the point back, now I'm going to enter into the OR operator is clear. Clear? Yes. Now I'm going to enter into the further. Now I'm going to enter into the further. So next one is called what you know? Operators. So go to the place here, bitwise operators. Let us keep it aside. So next I will go to one more kind of thing. What is the next one? And operator I'm going to take up. Very, very simple. And operator I'm taking. Let us start understanding about the and operator here. So and operator symbol I'm going to take up. So here and operator here. So this part I'm going to take up and operator. The functionality of and operator is shown in the truth table. Value 1, these are the combinations of integer data bits wise. I'm going to take it and operation here. Value 1 and value 2. So let us start understanding about the ANDing here. So let us start here. And means what? If both the values are called what? 1, result is 1. If any one of the bit is called what? 0, result is called 0. Start 0, 1, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1. So this is about bitwise and operator. Now I'm going to take up example number 1. Example number 1 I'm going to take. What is this now? 0 and 1. What is an answer? 0. 1 and 0. 0. 1 and 0 is 0. 0 and 0. 0. And 1 and 1. 1. So it is called 1. Coming to back. Coming to back to this place and try to see. 1 and 0 is 0. 0 and 1. 0 and 1 is 0. And 0 and 0. 0. 1 and 1. 1. This is called what operator? And operator. Already said product rule. Product rule. 0 into 1 is 0. 1 into 0 is 0. 0 into 0 is 0. 1 into 1 is called 1. Product rule. Now students, the point is coming to the place. Now I'm writing 3 and I'll write it. A is equal to 3, B is equal to 4. Second example case. C is equal to A and B. A and B. What is the value of 3 here? 0, 0, 1, 1. B is called what? 0, 1, 0, 0. So if I go to the AND operation, what is the answer now? Come on. 0, 0, 0. Answer is called 0. Answer is called 0. Print C. Print of C. 0. Are you following me? A and B. I am writing A and B. What is an answer? మీరు వేస్ట్ అసలు నన్ను అడిగితే A and B 4. 4 is an answer. So if I ask a question, if you take 2 minutes, 3 minutes, if you answer, nothing will come out of it. Already explained or not? Already explained. And please answer it. What is an answer? 3 and 4. Answer is called what? 4. 4. Already explained. 1.2, 1.2 and 2.3. It is called error. As I told that it is called what? Type error. Bitwise operators works on only integer, but it is applied on float. Now I will write 1.2 and a 2.3. 2.3. But AND operator works on what? Floating type. Next, I am writing C and see this operator now. C++ I am writing. C++ I am writing. It is going to give you what? Type error. Type error. So I am writing here. This is called a type error. If I write the same thing, I am writing here AND, which is called what? C++. C++ I am going to. Are you able to follow now? So coming to the point of it, C and what? C++. I wrote it C++ here. I think you are following me. So coming to the point of it, here I wrote it. Done. Go to the next case. I'm going to enter into the next case. Value 1, value 2, 2, something like this, we got it. Now, my interest is with AND operation, with a bit scene, with a 3 and 4, etc. Last and final, I'm going to say 10 and 15. 10 and 15. What is the 10 value here? 0, 1, 0, 1, 0. What is the 15? 1, 1, 1, 1. 4 ones. What is the answer? Come on. All AND operations here. All AND operations here. What is this? 0, 1, 0, 1. What is an answer? 10. 10 is an answer. Are you following me? Right. This is very easy, not a difficult. No formula directly available. Go to the next situation is A is equal to or S is equal to, go to the place, sets related I am taking. Set related data I am taking. Very, very important, students. S1, S2, now I am writing S1 dot, S1 dot union of, I am writing S1 dot union of, I wrote it. Today I am writing what? S1 dot intersection of, I am writing of S2 I am saying. S1 dot intersection of S2. S1 dot intersection of S2. What is an intersection will do? Take the common elements, put it into where? S3. Put it into S3. Print of what? S3 comma type of S3. Type of S3. The value is called what? 20. 20. The value is called 20. And 20 is available here. I think you are getting here called 20. Able to follow? Fine. Coming to this place, now I am getting 20 here. 20 is coming. I got the data 20. Next, I am going to enter into the another case. That kind of intersection operation. Internally, the intersection operation uses what? Bitwise AND. Take this S1 data, take this S2 data, and apply what? Instead of intersection, I am applying it as what? Ampersand of S2. S3 is equal to S1 ampersand of S2. What is happening now? S1. Come on, start comparing. The value called what? 10. Already I said the comparison. Be answerable and try to get the knowledge. Again, if you say, sir, explain again means it is a problem. What is this 1? 1. Compared with what? 1. What is an answer? 0. 0. That time it is not selected. Next 10 with what? What is the answer? 1 with 0. 0. Next 1 with what? What is that? So what is not selected? 10 is not selected at all. So next comparison with what? 20. 20, what is it? 1. 1. 1 with what? 1. What is that? 1. Under operation. Selected. Kept in where? Yes, 3. 20 with 15. 0. 20 with 25. That means in this comparison, 20 was not selected. 20 was selected in the first case only. Done? Well. So it is not an OR operator. It is called what? AND operator. Be careful. Come on, 30. What is the 30? 1. With what? Answer. Next, 30 with 15. 30 with 25. 0. Finally, what is not selected? 30. So in this comparison, what was selected? Only 15. That is 20 was selected. Next, go to the S2 elements with S1 or not. Come on, 20 with 10. At that point of time, 20 was not. 20 with 20. What is selected? 20 is adding to whom? But S3 already contains 20. Second time 20 will not be added. Next, 20 with what? That is 0. Next, 15. 1. 1 with 15 with 10. 15 with 20. 15 with 30. 0. That means 15 is not selected. Next, 25 with 10. 25 with 20. 25 with 30. 0. That is 25 also not selected. Print of S3. Print of S3, which is called 20. Are you able to follow? This is the way you need to explain. This is an internal flow. Suppose if I take it, S1 is like that. S2 when I am taking it, 21 when I am taking it, 21 when I am taking it, it is going to be called what? S1 and S2. S1 and what? S2. So what is the value of S3? Empty. It is an empty. It is an empty set because no common elements are available. That's why it is called what? Empty set. Even intersection also will give you the same approach or not? Yes. Now I am going to enter into the further. So I hope students you got a conclusion that set of empty and here you got it. One more last and final for your better understanding. 1.2, 3.4, 4.5. I will take it. S2 is equal to something like 7.8, 2.3, 2.3, and next is called what 1.2. I wrote it. Come on, now I am writing S3 is equal to S1 and what? S2. S1 and S2. Come on, start with 1.2 with 7.8 quick, 1.2 with 2.3, 1.2 and 1.2. That is getting selected and put it in where? Yes, 2.3 with 7.8, 2.3 and 2.3. Yes, 2.3. 1 point starts. 1 minute. 1.2 selected or not? Next what? 3.4. This one. 3.4. 3.4 with 7.8. 3.4 with 2.3. 3.4 with 1.2. 0. That will not select. 4.5 with 7.8. 4.5 with 2.3. 0. 4.5 with 1.2. So also not selected. Only what is selected? 1.2. Similarly, these place also 1.2 only getting. So other things are not going to get it. So I think I need not to go for the second task. You already understood. So S3 is going to contain what? 1.2. Got it out? Yes. Now I'll go to S is equal to something like this. Take your previous data, something like you take it. This is the data what we have. S1. Like this, you take the answer is like this. Start now. I am going to take up S3 is equal to S1 and what? S2. Start. Python with the Python 1. That is getting selected and put it into S3. Python with HTML. 0. Python with what? C, 0. Java with Python, Java with HTML, Java with C, right? Good. C with Python, C with HTML, C with C. What are the elements in S3? Python and C. And don't try to tell the answer. Try to see the flow. Flow is important here, right? HTML all with 0 only. Understood? So second one I am not going because you already understood that. So S3 we are going to, it is going to be containing Python and C. Clear up? Because this, how it works internally, that is an important. So answer anyhow you know, but how that is comparison is done, that is an important. This is about which operator, and this one is applicable only on sets, not applicable on other types. If you want to applicable on other things to this, convert into which type? Set type and try to apply. So are you following me? 1.2 and 3.4, 3.4. 1.2 about this, it will give you what? Error. Type error it will be given. So AND is completely different from bitwise AND. AND is completely different from bitwise AND. Take care of that. Now I'll move to the further. Bitwise AND operator I want to show you. Bitwise AND operator you see. Truth table is given in the table. Very, very simple. Truth table related thing. And the 10 and 4 calculation part is shown. And apple and mango, it is an error. And one more example I want to bring here. Beginning I shown you now. Here I said this part is there. This part I will carry this. Here I will try to keep it here. So 3 and 4. So I wrote it here 3 and 4. The value of C is going to be called what here? You got it. 0, you got it. This is an answer is called 0, you got it. So next is going to be called what? Apple and mango is called type error. 5 and 4. 4. 4 and 5. It is called 4. Any of the answer it is going to be remain same. But 5 and 4, 4 and 5, difference will come. So here 5 and 4, 4 and 5, different answer will come. But here if I write 4 and 5, same answer, 5 and 4, it is going to be same answer only. This is not differing like this type of symbol. This remains same. This is done. Because this is calculating with what? Binary bits. This is taking only in the case of short circuit evaluation concept. So this AND operator, bitwise AND is completely different from physical ANDing. I hope you are following this. So next, if we come to example number 3, intersection I am doing, done. Or instead of intersection, I am going to apply what? Bitwise ANDing I am applying. So the value 20. Next, I am going to take S1 and S2. S1 dot intersection of S2. S3 comma type of S3. We got the data like this. S1 is equal to S2 is equal to S1 and S2. S3 here. It is going to be called what? Mango here. Mango here. Are you able to follow now? That is a common value. In S1 and S2 also, floating point values I am taking. S1 dot intersection of S2. Got the data here. So now I am going to get it. Here I am going to get it. S1 and S2. S1 and S2 here. Bitwise AND operator. And the comparison is done. 2.3. 2.5 and 3.4. It is a type error. It is a type error. Unsupported operand types. Next, LST and tuple. If I apply on it, you are getting what? Type error. And if you want to go for list and tuple, in which case I have to convert into set. That time it is going to be possible. I think you are following me. So done. This is about which concept? Bitwise AND operator. Very, very important. Now this is done. So in this, we understood bitwise OR operator, bitwise AND operator. Now very, very important, bitwise complement operator I am going to enter. Bitwise complement operator I am going to enter, which is really under the people who are going to be learning this in deep of it. It's complicated. For any person, it is a complicated. And those who, if you follow me carefully, if you practice it and if you understanding now, it's a dead easy now. Let me start. No doubt in that, it is a complicated only. So Let me start with, I can make it very easy, but I don't want to make it you live like that, but I want to go in depth of it. Let us carefully follow. No doubt in that. Little complication is going to start. Enter. Syntax. Complement of value, I am going to take it. This is called bitwise unary operator we can call. You see students, double less than you see, here value 1, here value 2. Value 1 double greater than value 2. V1 or V2. V1 ampersand of V2. These are all called binary bitwise operators. Why? Two variables I am using, two values I am using to apply this bitwise operators. Now I am going to apply this complement operator on one variable only, on one value only. That's why it is known as what? Bitwise unary operator we can call. Bitwise unary operator we can call. Bitwise unary operator we can call. So complement of what? Value. Complement of value we are going to call it. This is known as what? Bitwise unary operator. Out of these many operators, this one only called as bitwise unary operator is called bitwise complement, because this was asked one or two times in the MCQs point. Out of bitwise operators, which operator is called bitwise unary? Which is a bitwise unary? Complement. Why it is called unary? Because it will take only one value itself. How it works? Now I am going to take up. Let me tell directly formula. Suppose if this question is coming, I don't know. Actually, it is a C language concept, but you did not learn it. Complement of A is equal to something like, something like 75. And the complement of A, what is the answer? Come on. What is the answer? Quick. So the answer is minus 76. Minus 76. Generally, no person can expect this answer. Complement means what I have seen it. People will say minus what? 75. They will say opposite to that, they will try to say. But the answer is minus 76. This is what is called a little complicated for the people who doesn't have any knowledge in computer science. No problem. Still, I can explain to you. So the formula for complement operator, bitwise complement operator is minus of value plus 1. Minus of value plus 1. So the point is, here note point is, whenever you write like that, the formula for that is known as what? Minus of value plus 1. Minus of value plus 1. Minus of value plus 1, which is known as what? Bitwise complement operator. Bitwise complement operator is that only. Minus of value plus 1. So the answer is what here? 75. What is the complement operator here? Minus of 75 plus 1, which is called as what? Minus of what? 76. Next, A is equal to 10. A is equal to 10. Complement of A, minus 11. Minus 11. How minus 11 is coming? Minus of value plus 1. Happy? But I am not happy. You are happy. నేను చెప్పేయచ్చు ఓవర్ అని. I can say over. I can say over. This is only the subject I can say. But when you go to interview, they will show HD cinema for you. How it is coming? They will ask you. How it is coming? Next, A is equal to what? Minus 28. Minus 28. Complement of A. Minus of what? A plus 1. Minus of what? Minus 28 plus 1. Minus of minus 27. Minus minus plus. What is that? 27. 27. 27. Answer is what? 27. How 27 is coming? Minus of value plus 1. అంతేనా? ఎందుకు అది వచ్చింది అసలు? Why that value plus 1 concept? What is the meaning of that? Nobody can explain you, including websites also. Take visit any website, you will not find what I am going to explain. See any website, any kind of thing, you will not get the answer what I am going to say. With this explanation, I can say you are happy, very happy. You can say these examples. I can say internal in the class, this is going to contain what? Value like that. This is going to be a value like this. Very happy you are. And this is going to be a minus 76. And this is a value we got it. Just 27 you got it. 27 you got it. Now I got it. Something like this. I think students, this is, I can say, it is over, I can say. What you will do? You will go with the same formula. You will answer. You can qualify in where? MCQs. No doubt in that. MCQs. But when you go to interview point of view, they will ask you complement of 10 is called what? Minus 11. Prove that. They will ask you prove that. Prove that. What you will prove? All each answer manaki. Minus complement of 10 is called what? Minus 11. అక్కడ మీరేం చెప్తారు? వాట్ విల్ సే? సార్ కాంప్లిమెంట్ ఆఫ్ 10 యు ఆర్ సేయింగ్ మైనస్ ఆఫ్ 10 ప్లస్ 1 దట్ ఈస్ కాల్డ్ వాట్? Minus 11. They are saying, I am also saying same thing. Complement of 10 is equal to minus 11. How you got it? Prove that. They are saying. What you will do? You will search in the internet. Type the same thing in Google. See any of the community platforms. You will not get the answer. Why? Because any product-based companies, if we go, they will ask this question. Shall I start that? Are you talented to understand what I am going to explain? No, sir. Mana talent ide, sir. Mana talent ide, sir. Only formula is our talent means happy. Happy, huh? Huh? Now I am going to in-depth discussion. In-depth discussion I am going to enter. What is the another discussion? One more discussion. Recently one faculty I have seen. I am Mahamedhavi. So, Mahamedhavi in the sense, అంటే ఎక్స్ట్రా ఇంటెలిజెన్స్, అది తెలివి అంటారు తెలుగులో, అది తెలివితేటలు. సో వాట్ ఈస్ దట్? కాంప్లిమెంట్ ఆఫ్ వాట్? 10. కాంప్లిమెంట్ ఆఫ్ 10, వాట్ ఈస్ అన్ ఆన్సర్? minus 11. He said take what is that value? That is called what? 10 plus what? 1, which is going to be called as what? Come on, minus 11. Right? That they are taking. That they are giving. What that faculty said is that this is what newly coming people in the teaching world, and they are trying to give the shortcut which is destroying the students' knowledge. The people who are coming newly to the teaching life, they are destroying the students' life like anything. These days I am watching it. So what they are doing? They are saying minus of, what is the binary of 10? 1 0 1 0. What is the next value? Plus 1. Plus 1 is called what? Plus 0 0 0 1. Correct? Correct kada? What is that now? Minus of what? 1 0 1 0. Raskondi, why are you writing? Why are you writing? Are they correct or what? If you write like that, it is a problem. Don't write. 1 0 1 0. And next is called what? 0 0 0 1. What is the answer they are saying? Come on. 1 1 0 1. What is the answer of this? 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. What is this? 8 plus 2, 10. What? 11. Of what is available here? Minus. What is the answer they are saying? Minus. ఇది కూడా అదే కదా, సేమ్ కదా అది. Like that they are mismanipulating the students. What they are saying? Minus 1 0 1 1 they are saying. That is called minus 11 they are saying. What student will do? You will write in the notes. You will write in the notes. It is nothing but addition only. You are taking 10 binary, one you are writing, you are going to do this. Are you following? Are you following? Now, if that is the case, my question is, come to the point. What is my question? What is my question? You see, my question is 16. My question is 16. My question is what? 16. Something like 15 you take it. 15 you take it. 15. 15. 15. Complement of what? 15. And those who said this type of answers and how they are disturbing the students, I cannot imagine. Recently, one Python faculty saying like that. By saying that, myself got very much tense about it. So, complement of 15. What is an answer? Come on. Minus of what? What that faculty is saying? Plus 1. What is the 15 value? What is the 15 value? Tell me. Minus of what is the 15 value? 1, 1, 1, 1. What is the value next term? 0. What is this answer now? What is an answer? 0, 0, 1 or not? What is an answer now? Come on. 1, 1, 1, 1. What is an answer? 15, 15. What is the answer supposed to get it? According to that fellow. What is that answer? Minus 15 is an answer. Huh? Hmm? Then, then, tell me. Tell me then. Complement of what? 15. What is an answer? But what is an answer that fellow got? That is, on the spot, they are taking their own U-turns. And a student will not ask this doubt. If I am a student, I will compulsory ask the doubt. Student will not ask the doubt. Then what to do then? Is that important or not? That's why these type of seasonal business will disturb the student. Seasonal business center then. Because of their survival, they are coming and disturbing the students. It is my advice to you people. Any fresher is coming and explaining the topics, completely destroying you. That's why very, very be careful about these things. Online students, are you following me? Now I am entering into the subject. Can I enter? Will you understand? Yes. Let us start understanding about this. Because I watched it 10 to 12 recent people who are coming into the teaching division. I observed it. Completely blunder they are teaching. Completely blunder. Doesn't have any academic subjects. Failed candidates, I feel that. No, not even good communication. Nothing. And they are disturbing the students. Coming to the point back. Now I am entering into the bitwise complement operator I am going to discuss. Shall I start? Now, are you, first of all, remember this formula. Remembering formula is compulsory. What is the formula? Complement of value is equal to minus of value plus 1. Now I am going to start. Now I am going to start. Proofs I am going to talk. Proofs I am going to talk. So first of all, you must understand binary addition I want to tell you, plus another small concept I want to tell you. In computer science, I'm going to enter because computer organization I'm going to tell how the data internally organized I am talking. In computer science, of whatever the subject you will learn it, any programming language you will learn it, all negative numbers in any language, it is a common concept I am telling. All negative numbers are stored in main memory. In main memory, you already know main memory. In main memory, in the form of 2's complement. 2's complement. I will tell you, student, don't worry. 2's complement. 2's complement. All negative numbers are stored in main memory in the form of what? 2's complement. All negative numbers are stored in main memory in the form of 2's complement. Sir, what is this 2's complement? I will tell you. 2's complement of a number is equal to 2's complement. Listen very carefully. Again asking, difficult to explain. 2's complement of a number is equal to 2's complement of a number is equal to 1's complement plus 1. 1's complement plus 1. Because this concept was designed by the computer scientists for storing negative numbers for high optimization purpose. For signed values is concerned, they are converting into 2's complement. You need to start with a 2's complement concept onwards. So all negative numbers are stored in the form of what? 2's complement. 2's complement is equal to what? 1's complement plus 1. What do you mean by 1's complement, sir? I am going to write it. 1's complement is equal to 1's complement is equal to 1's complement of a number is equal to number is equal to inverting the bits. Inverting the bits. Inverting the bits. Inverting bits is nothing but inverting bits is nothing but is nothing but is nothing but 0 becomes 1, 0 becomes 1, and 1 becomes 0, and 1 becomes what? 0. 0 becomes 1, 1 becomes 0. That is called inverting. Inverting అంటే ఏంటి? Opposite. 0 becomes 1, 1 becomes what? 0. That is called negative numbers storage history. All negative numbers stored in main memory in the form of 2's complement. You take any working employee, ask this question, completely out of order. When we reach to the high end stage in the Java coding, that's why we are able to know this type of complete history of what is happening about negative numbers. All 2's complement of a number is equal to 1's complement plus 1. 1's complement of a number is equal to inverting bits. What do you mean by inverting the bits? Inverting the bits is nothing but 0 becomes 1, 1 becomes 0. That is what you are learning here. 2's complement and 1's complement. What is 1's complement? Inverting the bits. Inverting means what? 0 becomes 1, 1 becomes 0. What is 2's complement? 1's complement plus 1. 1 is nothing but 0, 0, 0, 1 format. Okay. Is it clear, students? Online students, respond. Quick response is required. Because after seeing that with my own ears, I heard about that thing what they are misguiding. That is the value of value minus 1, converting it to binary, adding 1 to it. It will become mathematics formula only now. Are you following me? They are trying to give you what? Some pain is there. On the pain, they are giving painkiller. After 2 minutes, again the pain will start only. Because of that thing, students will become problem. Because this person is staying there only. And you people are going to an interview point of view. And you are facing, finally you'll get a problem. Whatever they like it, they are going to explain. That is the main problem. Come to back. Now I'm going to say, in computer science, this is a situation you got it. This is a situation you got it. Done. Now I'm going to tell you about binary addition rule. I'm going to tell you, students. Binary addition rule I'm going to tell you. Binary addition rule is there. Binary multiplication rule is also there. Take any working employee, ask these questions. 90% don't know. 90% don't know. 100% you test it. Now binary rule I am going to tell you. What is the binary rule? Binary bits are what? First of all, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0. How many combinations? Number 1, 0 plus 0. Answer is 0. That is first combination. Next combination. All these things I am giving in the notes. First listen. And the notes don't. Everything is there in the notes. Don't write anything by yourself. Everything is there in the notes which I am going to give you. First listen. Second one I am talking about 0 plus what? 1. Answer is 1. Third combination. 1 plus what? 0. Answer is 1. 0 now. 1. Next, fourth one is called what? 1 plus 1 is called. వినండి మీకు తెలియదు కదా వినండి. Don't know, listen. This is going to be called 0 with carry 1. 0 with carry 1. Binary addition I am doing. I'm not talking about and. I'm not talking about and. I'm not talking about or. I'm talking about binary and operation. Binary and binary or I'm not talking. I'm talking about binary addition rule. 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1, 0 with carry 1. చెప్పండి సార్. Yes. Now, look at, చూడండి ఒకసారి. 2 plus 3 is equal to 5. Prove that 2 plus 3 is equal to 5. It is the question in Infosys. 2 plus 3 is equal to 5 only. You also know, I also know. But how you got it? How you got it? Maybe BTech, MTech, PhD is also over, but they don't know subject. What will happen? Same problem. So you have to go for what? Take the binary form. What is the binary form? 0, 0, 1, 0. What is the 3? 0, 0, 1, 1. Start. Remember my rules. 0 plus 1. 1 plus 1. 0 with carry 1. 0 plus 0. 1 ఎవరైనా బయటపడేసి తీసుకుపోయి. 0 plus 0. 0. 0 plus 1. What is the answer? 1. 0 plus 0. 0. What is the answer? 2 to the power of 0. 2 to the power of 1. 2 square. 2 cube. 1 into 2 square. 4. Plus 0 into 2. 0. Plus 1 into 2 to the power of 0. 1. Answer is what? 5. This is the rule. ఏమన్నా అర్థమవుతుందో? Understanding? Yes. Next. 15 plus 1 is equal to 16. 15 plus 1 is equal to 16. Prove that. Come on. 1, 1, 1. ఇక్కడ ఇలా రాసుకోవచ్చు కదా. 0, 0, 0, 1, 1, 1. Correct. Next. 0, 0, 0, 0, 0, 0, 0, 1. Come on. Start. 1, 0. Come on. 1, 0. 1, 0. Come on. 1, 0. 0, 0, 1. 1. Like this. Like this. What is the answer? 2 to the power of 0. 2 to the power of 1. 2 square. 2 cube. 2 to the power of 4. What is the answer? That is the subject. It is subject. If you take any outsider, what is the addition rule? All addition రావు. Normal additions only don't know. Binary addition that too. Binary multiplication also I can tell you. These are questions in big product based companies. Are you following me? So, what is the 16 value? What is the 16 binary? ఇప్పుడు చూపిస్తాను మీకు. 16 binary already you know. Binary of 16. What is the answer? 4 zeros and 1 is coming or not? Did you understand? Well, now I will move to the further. Binary addition rule. చెప్పండి ఒకసారి. 0 plus 0, 0. 1 plus 0, 0 plus 1, 1 plus 1, 0 with carry, 0 with carry, 1. And you have seen the binary addition also. Okay now? Good. Now I am entering into the further. Shall I move to the further? Go to, this is the fundamental concept completed. Go to the next one. Online students, can you respond once? Quick response is required. Is it clear up to here? Now, I am entering into complement operator once again. I am bringing it. So I am bringing the syntax. So what is the internal functionality of complement operator? The Internal functionality of the internal functionality of bitwise complement operator, bitwise complement operator, bitwise complement operator is that to invert the bits, to invert the bits, to invert the bits, to invert the bits. Now start. I'm going to talk about example. Example. Start here. What is my concept here? Example. First question. First thing. Complement of what? 10. Complement of 10. Start. First you take it. What is the complement of 10? Answer is what? That you keep in the mind. That you keep in the mind. Now, what is that? Complement of, what is the binary of 10? 1010. Correct? 1010. That is called what? Complement of 10. What is the bitwise complement operator says? Invert the bits. What do you mean by inverting the bits? 0 becomes 1, 1 becomes 0. Sleeping. 0 becomes 1, 1 becomes 0. Important concept మనకు నిద్ర వస్తుంది. 0 becomes 1, 1 becomes 0. Answer. Come on. Answer. Come on. 0, 1, 0, 1. 0, 1, 0, 1. What is an answer? Come on. What is an answer? 5. But it is not 5. What is an answer? Minus 11. Minus 11. ఇంకోసారి చెప్తాను. Another I will tell you. 0, 0, 0, 0. Is it a binary 8-bit format of what? 10. 8-bit format of 10. Inverting the bits. Come on, invert the bits. Come on. Everybody. 1, 1, 1, 1. 0, 1, 0, 1. This is called what? Result of what? Complement of 10. What is this answer according to your subject? According to your subject, what is this answer is called? 0b. 0b. I will say 0b. Like this I am writing. This I will carry. This I will carry. This one I carried. So 0, 1, 0, 1. So you try to print this A students. You try to print this A students. You are getting the answer is what? 245. 245. Even if you do 2 to the power of 0, 2 to the power of 1 like that, 245. 245 is the wrong answer. But what is the significance of that? This is an answer you are getting in the internet and every place they will say. But what is this? They will say straightforward. It is called what? Minus 1100. Is it a minus 11? Huh? No. But how it is minus 11? I'm going to tell you. Which is the binary form of, which is a binary format of minus 11. Which is a binary format of what? Minus 11. Sir, how do you prove? That is what is called prove that complement of 10 is called what? Minus 11. Complement of 10 is called what? Minus 11. Complement of this operator will do what? Inverting the bits. This is the original format of 10 and I inverted the bits. I got this result, which is a binary form of what? Minus 11. What is the minus 11? What is the minus 11? Muddubovulu. What is the minus 11? Negative number. Negative number stored in the memory in the form of what? 2's complement. So remember, all negative numbers are stored in the form of what? 2's complement. Correct or not? 2's complement. Okay. So minus 11 is a negative number. For which number? What is the minus 11 positive? Minus 11 ko positive enta? 11. 11 positive. Whose counter opposite is what? Minus 11. 12. Minus 12. 13. 14. Minus 14. 14 minus 16 minus 11. Huh? No, minus 11. So minus 11 is what? Negative number of what? 11. So we need to take which number? Here, minus 11 is the counter opposite of what? 11. 11 ka opposite of minus 11. Opposite plus opposite of that will add it will become 0. Right or not? So minus 11 counter opposite is called minus 11, or counterpart of minus 11 is called 11. So we start with what? 11 onwards. So take 11. Take 11. Are you following me? Our answer is what? What is an opposite of minus 11? Take 11. Take 11. I am proving the reverse engineering concept I am taking. Take 11. And whose binary format is? Tell me. Come on. 1 0 1 1. 1 0. That is the binary format of 11. ఇక్కడ చూద్దాం. Bin of what? 11. What is the answer? 1 0 1 1. But it is going to be 4 bit. Now I am writing like this also. Can I write like this? Yes. Now, what I want to find out? Minus 11 value I want to find out. Minus 11 is nothing but what? Negative number. Want to store it in the form of what? If you want to get 2's complement, what I should do? So I need to find what here? 1's complement of what? 11. 1's complement of what? 11. What is the 1's complement of 11? Inverting the bits or not? What is the inverting the bits? 1 1 1 1 0 1 0 0 0 0. Are you following me? Next, what I want to get it? 2's complement. 2's complement of 2's complement of 2's complement of what? 2's complement of 11 is what? 1's complement of 11 plus 1's complement of 11 plus 1. What is the 1's complement of 11? Come on. 1 1 1 1 1. There is no hurry at all. Relaxly do that. 0 1 0 0. What is the next value here? 1. What is the value you are doing? Come on. 0 0 0 0 0. 0 0 0 0 1. Correct? What is the rule you are applying? Binary addition rule. Binary addition rule. Binary addition rule. Come on, start with 0 and 1. Yes, tell me. 1. Next 0. Be careful. Next 1. Next 0. Next next 1. Next 1. Next. Is it not the value of like this? Is it the value or not? What is this 1 1 1 0 1 0 1 0 is called? This one, which is called what? 2's complement of 11, which is known as what? Minus 11. It is subject. This is a subject. This is the first example. Come on, answer you. Second example, I'll tell you. Third example, I'll tell you. Come on, answer 1 1 1 0 1 0 1, which is called what? 2's complement of what? 11, which is known as what value? Minus 11. This is the value is equal to this value only. Malla తీసుకుందాం. Second example. Online students, here did you understand at least 20%? 20%. 100% no, 20%. బిత్ర చూపులు చూడకుండా చెప్పండి. Are you following? Right. So, coming to the point of it, I'm going to enter into the second one. I'm going to. So now I'm going to take it. One more thing. Take the complement of what? Directly I will take 5. 5 5. What is the complement of 5? Complement of I will take up What is the value? 0, 0, 0, 0. And what is that? 0, 1, 0, 1. 1, 0, 1. What is the answer now? Inverting the bits. Complement operator will do what? Inverting the bits. What is the inverting the bits answer? 1, 1, 1, 1. Next answer 1, 0, 1, 0. Suppose if we give to any unknown person, what is 1, 0, 1, 0? 10 they will say, but it is not. This is the value of what? Value of what? Minus 6. Sir, how do you know minus 6? Apply the formula. Keep the formula. What is the formula? Minus of value plus 1. What is the minus of value plus 1? Minus 5 plus 1. Minus of 5 plus 1. This is called the negative value of what? Minus 6. Come to the proof. Come to the proof. Come on, take the proof. What is the proof? What is the value you got it? Minus 6. What is the value need to take? 6. Take 6. Take 6. Whose binary format? Tell me. Whose binary format? Quick. Come on. 0, 1, 1, 1, 0. ఇక్కడ చూసుకోండి. చెక్ చేసుకోండి. Bin of what? 6. What is the answer? 1, 1, 0. So that added extra. Here I will add 4 more zeros also. It is called 8-bit register or not? Yes. Come on, start with. Basically, I need to find what? Minus 6. Minus 6 is called 2's complement. 2's complement of 6 is equal to 1's complement plus 1. Come on, fast. 1's complement is equal to 1's complement of what? 6. 6. What is the 1's complement of 6? 1, 1, 1, 1. Come on. 1, 0, 0, 1. 1. Next, what is that? 2's complement. 2's complement of what again? 6. 2's complement of 6 is equal to, come on, 1's complement of 6 plus 1. 1's complement of 6 plus 1. What is the 1's complement of 6? Already it is here. 1's complement of 6 is this one plus what? 1. What is the 1 here? 0, 0, 0, 1. 0, 0, 0, 1. Answer that. Binary addition rule start with 1 and 1. 0 with carry what? 1. 0 with carry what? 1. Next 0 plus 0 plus 1. 1. 0 plus 0. Okay. What is this now? 1. What is this now? 1. Next 1. 1. 1. Is it the value similar to this value only now? Which is called inverting the bits of the given number is nothing but a negative number is coming or not? This is the practical meaning of it. So here 1, 1, 1. What is this now? 1, 0, 1, 0, 1, 0. This is called what? 2's complement of what? 6. 2's complement of 6 is called what here? Minus 6. Malla last law. Inకొకటి. Third time. Did you understand 80%? ఇంకా 20%లో ఉందా మన రీడింగ్? Is your reading went to 60 or 80? ఆ 0 reading. అసలు మిషన్ పని చేయదా? If machine is not working, you try to do something else. Don't learn computer science. Come to the point of it. Actually, ఇక్కడే చెప్పేసాను అనుకోండి. Complement of value, minus of value plus 1 is called what? Over. You also very happy. Why? Sir is asking complement of 16 minus 17. Complement of 20 minus 21. You'll be very happy. But this is coming, people will get problem. Why? Success things are always very difficult. Correct? Now, come on, start with complement of what? 15. Complement of what? 15. Start. Answer is what? Complement minus 6. నాకు ఆన్సర్ వద్దా, నాకు ప్రూఫ్ కావాలి. Who asked you answer? I want to prove. Sun rises in east, proof. Moon. Moon is cool, proof. Sun is hot, proof. We don't know that. But subject what we are learning, we need a complete expertism. Come on, complement of what? Come on, 0, 0, 0. Now So, right, Somnath is saying, sir, why 8-bit? You 16-bit, what is there? 16-bit you just said. These doubts are going to be completely complicated, where this will give you some irritation. Yesterday I said what? 4-bit, 8-bit, 16-bit, 32-bit, 64-bit. If you are having patience, you take that. Why 8-bit only? I already said now. 4-bit. 4-bit means what? Maximum how much value? 15. 16 is 4-bit is enough. I went for what? 18. 8-bit. 8-bit is called what? 8 ones. What is the value? 255. More than all 8 ones is over, it will go to more than that or not? I'll go to what? 16-bit. Yesterday only I said no. Why 8-bit, sir? Why 22-bit, sir? Because of that answer, that type of faculty is only suitable. Because they will not make you to open the mouth, they will not make you to think about the subject. Why 8-bit? Already yesterday only I said. So, now coming to this. Come on. 0, 0, 0. Come on, next. Come on. 0, 0, 0, 0. And 15. 1, 1, 1, 1. What is this is called? 16-bit register capacity of number 15. Understood? Right. Somnath, come on. What is an answer? Come on. Why are you getting? Come on, start. 1, 1, 1, 1. No. 1, 1, 1, 1. 1, 1, 1, 1. 0, 0, 0, 0. What is this is called? ఏమిది? Which is called minus 16. What is the minus 16? 2's complement of 16. This is the value, which is the value of, this is the value of, this is the value of, this is the value of minus 16. Minus 16. People will wonder how it is minus 16. They'll say 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Here value will be coming. People will really wonder. So, even internet, any internet, today morning to evening, night, tomorrow up to this time you watch it, you will not find this proof. This is given, but they won't say why this is coming. They won't say how this is coming. Why? Of knowledge. Now come to the point of it. What number you will take? Come on. What is minus 16? What is minus 16? Counter opposite of 16. So take what? 16. Take 16. Whose binary form this konde? Binary form. What is the binary form? What is the binary form? Come on. 0, 0, 0, 0, 0, 0, 0, 1, 0. Next up, 0, 0, 0, 1, 0, 0, 0, 0. What is this? 16-bit binary representation for 16 number. Somnath. Got it. What I want to find? 2's complement of 16. 2's complement means what I want? 1's complement. 1's complement of what? 16. 1's complement of 16. Come on, start. 1, 1, 1, 1. 1, 1, 1. 1, 1, 1, 0. 1, 1, 1, 1. Okay now? Come on, next term. 2's complement of 2's complement of what? Yes. 2's complement of 16 is equal to, what is this now? Come on. 1's complement of 16 plus 1. 1's complement of 16 plus what? 1. So coming to this point, so this point I will take it. This point you take it. Plus what? 1. What is the 1? 0, 0, 0. 0, 0, 0, 0. 0, 0, 0, 0. 0, 0, 0, 0, 1. Start. What is the rule you are applying? Binary addition rule. How beautiful it is. Start. 1 and 0. 0 with carry 1. Okay. 1 plus 0, 1. 1 plus 1 is what? 0 with carry 1. 1 plus 0, 1. 1 plus 1 is called what? 1 with 0 with carry 1. 1 plus 0 plus 1. 0 with carry 1. 0 plus 0. 0 plus 0 1. మున్సిపాలిటీ వ్యాన్ రెడీగా ఉంది అక్కడ. సో 0 plus 0 0. ఎక్కడ తీసుకెళ్తారు తెలుసు అది? 0 plus 0 0 plus 1. What is the answer? 1. 1 plus 0 1. Next 1. Next 1. 1 1 1 1. 1 1 1 1. Which is an answer of what? This one. This is called minus 16. ఇది సబ్జెక్ట్. అర్థమవుతుందో? రైట్. దిస్ ఇస్ ద సబ్జెక్ట్. Come on, what is an answer? 1 1 1 1 1 1 1 1 1 0. What is that? 1. What is this answer? 0 0 0 0. ఇంకెక్కడ 1? So here, yes, this is going to become 1. This is going to become 1. This is known as what? 2's complement of 16. 2's complement of 16. That is called what? Minus 16. Minus 16. Here just we are inverting the bits, which we are calling it as. Remember the formula, immediately say that minus 16. How minus 16? They will ask you. You prove that how it is minus 16. Hence you are proved that minus 15 is called what? Minus 16. Understood? It is subjective. Then tell me, have you learned this topic in your CSC? అసలు ఇది అంటే ఏదో తెలియదు మీకు. This you don't know, first of all. This is called a subject. So online students, of course, what is your reading? 20%. I set some different reading intervals. All the students in the online, what is your reading? I want to know. Quick. I need to answer. I need to know quickly. Online students, I think they become stagnant. Online students, are you Uma? 80%. Okay. So other students, Priya 80%. Now అందరు ఇప్పుడు 80% మీద వచ్చేస్తారు. ఇప్పుడు ఇంకేం లేదు, అయిపోయింది. ఇంకా 80% is nothing but very low. సో 75%. మేబీ కొంతమంది 5% కూడా ఉంటుంది. అంటే ఇట్ ఇస్ అ డిఫెక్ట్ పర్సన్, వీ కెనాట్ డూ ఎనీథింగ్. సో 70%. సో Panindra, doubt. So Ravikumar Yadav, 100%. Okay, this is a subject I explained with binary calculation, completely with practically I shown you. Come to the point. So now syntax. The execution process of bitwise complement operator is that it inverts the given bits. Inverting the bits is nothing but 1 becomes 0, 0 becomes 1. The formula for bitwise complement operator is given below. Complement of given number is equal to minus of given number plus 1. Complement of A, 10 here, and at 100, it is a number. Minus 123 is 122. Now proofs will be starting. Prove that complement of 10 is minus 11. Given complement of 10 is minus 11. Here minus 11 is an opposite counterpart of 11. That is called 2's complement of 11. Given number is 10, whose binary part is what? 0 0 0 1 0 1 0. Complement of 10, this is a complement of 10, which is called inverting the bits, which is nothing but binary form of minus 11, which is called 2's complement. All negative numbers are 2's complement of their positive numbers. 10, whose counterpart is minus 10, which is a 2's complement of 10. Here minus 11 is an opposite counterpart of 11, which is a 2's complement of 11. All negative numbers stored in main memory in the form of 2's complement. 2's complement is equal to 1's complement plus 1. So here I am taking here 11, whose binary format is this one. 1's complement of any number is equal to 1 becomes 0, 0 becomes 1, which is called what? Inverting the bits. 1's complement of 11 is called what? 11 is called this one, whose complement, 1's complement is called inverting the bits. So all 4 zeros becomes 4 ones. 1 0 1 1 becomes what? 0 1 0 0. 2's complement of 11 is equal to 1's complement plus 1. This value plus what? 0, 0, 0, 1. Binary addition rule I said. 0 plus 0, 1 plus 0, 0 plus 1, 1 plus 1. Everything I wrote it. And I wrote it here. I wrote it here. The addition I made it. 0 plus 1 is called 1. 0 plus 1 is called 1. 0 plus 0 is called 0. 1 plus 0 is called 1. 0 plus 0 is called 0. 1, 1, 1 and 4 zeros and got it. Prove that minus 16 is called minus 17. Minus 16 is minus, complement of 16 is minus 17. Here minus 17 is an opposite counterpart of 17. Given 16, whose binary part is this one? Complement of 16, this is the one, and we are getting this answer, which is a binary form of 17. Minus 17, already explained, opposite of counterpart of 17. All negative numbers stored in 2's complement. 2's complement is equal to 1's complement plus 1. So take the 17 here, binary format. 1's complement becomes this one. 1's complement of that, this is called your binary form of 17. And this is a binary complement. 1's complement, inverting the bits. 3 zeros becomes 3 ones. 1 becomes 0. 3 zeros becomes 3 ones. And this is 0. 2's complement of 17 is equal to 1's complement plus 1. This is the number. Plus 1 is added. Binary addition rule. And done. Next, prove that complement of 15 is equal to 16. Already just now shown. Here it is 4-bit, 8-bit. I shown you in our example 16-bit place I shown you. This is the answer we got it. This is an answer we got it. And here extra what I mentioned it. I went for what? 16-bit also I mentioned. So this is the topic of what? Bitwise complement operator. With this నేను ఫినిష్ చేసేయచ్చు. Complement of value is equal to minus of value plus 1. Very happy. అది అలా చెప్తా ఉంటారు బయట. They will say like this. But when you go to any big companies, very big companies, they will ask this. So that to the person who is asking that, they should have the knowledge about it. And if you answer it, you should have the capacity to understand also. And without your basics, I said you, what is that? All negative numbers. I gave the introduction for you. Introduction I gave. And binary rule also I said. Everything basic level onwards I explained. And this is called bitwise complement operator. So answer is what? Complement of 78. What is an answer? Answer వచ్చేసింది. But how you got it? అప్పుడే లేనిపోని ఇబ్బందులన్నీ వస్తాయి. ఎక్కడ లేని కష్టాలు వస్తాయి అప్పుడు. దాన్ని ఏం చేయాలి? How to overcome that? Convert 79 into binary. Inverting the bits. That is 1's complement. Plus 1. You will get what? Value. That is called what? Minus 79. After inverting the 78, you will get minus 79. Just only 2 minutes job. So I explained systematically point to point. That is called bitwise complement operator. Actually, fifth one is a difficult one. Why difficult one? Student doesn't have that much power to catch it. Why? Whatever the people you come across in your teaching career, all of them are showing something blackboard, white chalk piece, paper and pen job. No calculation, no pakka proofs. They did not come across. Because our brain also tuned like that. From beginning onwards, if they teach application level, by this time it is different. Anyhow, I hope you understood. Next class, when I come back, I will talk about what? Bitwise XOR operator, I will explain. Bitwise XOR operator, I will explain. Don't miss that. After completion of this bitwise XOR operator, again I will explain symmetric difference tomorrow. Do you know symmetric difference? Sets union, intersection, symmetric difference. That part will be done with what? Bitwise XOR operator. After that, bitwise operators completed. Yesterday completely, today completely, tomorrow also, and tomorrow also up to half an hour. Then I will enter into where? Membership operator I will explain. I will enter into. So don't miss tomorrow class. Thank you, students. All the best. Carry on. Don't miss tomorrow class.